welcome to Our Product is Production Traffic. Thank you for spending a little bit of your time here at Spring One with me. On reflection, I really should have just called this talk How Pivotal Runs Cloud Foundry, because that's more what it is and more like comprehensible more immediately, like what's that about. Though then there's a whole bunch of caveats and like, okay, we're only one team that runs Cloud Foundry out of the various teams that run Cloud Foundry at Pivotal. But that's really what this talk is going to be about, is the Cloud Foundry that we run inside of Pivotal Web Services, and then the team that runs it, and some of the experiences and challenges and learnings that we've had over the last 6 months. So I'm Natalie Bennett. I am currently the anchor of Cloud Operations, or Cloud Ops. That's the team that runs the Cloud Foundry in Pivotal Web Services. I've been an engineer on a couple of different teams: core services, release integration, billing and accounts management. So I've seen a variety of different parts and pieces of the system, from some of the database services that we deliver to the billing system to now Cloud Operations itself. Follow me on Twitter, or we'll come back to that, the CF Operators channel. Pivotal Web Services, you probably know what Pivotal Web Services is, but just in case, a little refresher. Inside the office, we affectionately refer to it as PDubs, given that's you up front, because I am not going to be able to remember to say all the syllables in Pivotal Web Services all the time. I'm going to start calling it PDubs at some point, so just watch out for that. It's a publicly accessible Cloud Foundry, so that means that anybody can go to run.pivotal.io and sign up with a phone number. Actually, you don't even need a credit card, and then within 15 or 20 minutes be pushing an app. It also contains a billing system and services. I bring that up because we don't run those things. Those are actually run by other teams. So that's one big difference between the job that I have and the job that a customer running PCF is going to have, is I'm not responsible for the Rabbit tile. I'm not responsible for the Redis tile. The Rabbit, the Redis, the MySQL teams, those teams run those services themselves. Likewise, many of the services that are available on Pivotal Web Services are actually run by AppDirect, one of our partners. So Cloud Ops itself, the team, is 8 engineers and a PM. You maybe have heard that we run with 2 engineers or 4 engineers or some number that's very frighteningly small. We do have 8. That number has gone up and down over the years, but we found that while you technically can run Cloud Foundry for a little while with 1 person, with 2 people, 6 months later, a year later, you're going to lose those people. They're either going to get tired or burned out, or they're going to quit, or it's not sustainable. So you do need, I think at minimum 4 people, and probably more than that if you've got an on-call rotation. In San Francisco, we have 3 of those pairs, so that's 6 engineers. So we are co-located then with main sort of core runtime R&D, most of core runtime R&D, less than it used to, but many of those teams are still in San Francisco and 875 Howard, right down the street, which is really, really nice as an operations team. Another thing that's really different about my job versus the job that a PCF operator in the field is going to have is I can walk over to the Bosch team. If Bosch is doing something that I don't expect, they are literally 2 rows over. I sit across from Cappy, the cloud controller team. So if I need help with one of those components, I can just get them right there, which is really nice for me. Maybe somewhat less nice for them, although, they keep coming over. We recently, the last 3 or 4 months, added a Toronto pair. Did you know that Toronto is the world's raccoon capital, raccoon capital of the world? Right, I never shut up about it. They will come and scream in your pool. There's a documentary on Netflix about this, Raccoon Nation, but, Toronto. I couldn't find a good picture of the CN Tower, so I was like, okay, raccoons, just emergency button, cute animals. We added this pair around the same time that we used to have a Follow the Sun 24-hour on-call rotation with a team in Beijing. And we found that that was too big of a gap. That was too far. It was too big of a handoff. We didn't pair with them directly. We couldn't. And so their experience of that was, hey, the San Francisco team is interrupting something that you're doing to drop work on you at the beginning of your day, at the end of their day. And our experience was, the Beijing team silenced that alert a bunch of times last night. I wonder what was up with that. Was that something important? We don't know. And so we pulled back from that 24-hour on-call. We pulled back from the follow the sun. We actually put engineers in San Francisco on 24-hour on-call, but around that same time, we added the pair in Toronto, and that gives us some coverage outside of regular pivotal working hours in San Francisco. That's something I should mention, actually. We work 9 to 5. We work 9 to 6. We go home. If there's a deploy running, we still go home. That's really nice. That's something the Cloud Foundry lets us do. But it shapes, the desire to retain that shapes a lot of decisions that we make about how to run the platform. The other thing that's nice about Toronto is we do, I mentioned that we don't run the services. We do have some cooperation with those teams. We share the same basic IaaS AWS infrastructure. And so we do have some coordination that we need to do with them. Very nice to be able to do some cross-team pairing in the hours that overlap between the East Coast and London, because that's where those teams are. And then our PM, of course, who's in the audience right there, she's in Pittsburgh. So we are an extremely distributed team. We spend a lot of our time in video chat meetings. That has had challenges, but it's also been, had a lot of advantages. It allows us to have people who otherwise wouldn't be on the team, and it also makes us more accessible to people who aren't in the San Francisco office. The better we are about being in Slack, being available in video chat, the easier it is for people who are outside that little tight face-to-face bubble to see what we're doing and understand what's going on. But Marie will tell you that we're not, we don't always quite, we're more aspirational in how good we are at that. We're getting better, but it's still definitely frustrating. It's more frustrating to be on the other side of that than to be on the San Francisco side, as I am. CloudOps principles, I want to bring this up really early on because when I rolled on, basically the idea was, well, how do we take the SRE book and extreme programming and bring them together on operations? We've had a variety of different eras in CloudOps, and some of those have been better than others. Around 6 to 8 months ago, we were having a lot of those classic problems, I think, the problems that led to movements like DevOps of the dev team says the ops team isn't giving them what they want. The ops team says the dev team doesn't listen to them. Nobody's happy. Nobody's happy that nobody is happy. And so we did a fairly big reset of the people who were on the team. We brought a bunch of new people on. We rolled a bunch of people on from other CF development teams. So like I was previously on the core services team. We've got several people who were previously on the cloud controller team. We've got people who used to be on Bosch. We rolled a bunch of the people who had only ever been on CloudOps and only ever been in operational roles actually onto other development teams, and then we rolled a bunch of developers on. So we did this relatively radical, like, supercharged DevOps. Like, it's all going to be the same allocations pool. And at the same time, we were like, let's refocus on these things that we know that work: incremental change, tight feedback loops, shared knowledge, mutual respect, simplicity. Like, these are things that I really, really believe in. And they shape a lot of how we make decisions on CloudOps, what we do and why we do it. Again, aspirationally. We do ship bigger batch sizes than we would like to, and then we go, oh, sure was hard to figure out which of those changes in that big change set. We thought this was going to be faster, but actually, when you count in the time that we had to spend rolling back, not faster. I mentioned a couple of differences. We're about to get out of the intro stage and into the funny animal picture stage. I mentioned a couple of differences between PWS and PCF. I want to go over a few more real quick just to lay some groundwork. You're probably familiar, if you run CloudOps, if you run Cloud Foundry yourself, you're familiar with our quarterly release cycle. We actually run open source Cloud Foundry. So we have a bi-weekly release cycle. So we're deploying Cloud Foundry at least twice a week, often more. So that's different. We have direct Bosch control. We don't use Ops Manager. We don't go through Ops Manager. That used to be more of a challenge than it was. Now the open source actually provides a lot of the things that Ops Manager has traditionally, like the really, really painful things that Operations Manager solve for you, things like laying down your basic IaaS paving or managing credentials. There's better tools for that on the open side. There's still drawbacks, but we've gotten a lot of support in that area recently. The services teams run services. If you're in PCF, you probably run services tiles. And then our tenants are customers, so they're not coworkers, which, again, has advantages and disadvantages. It means we actually often aren't interested in application metrics or what applications are doing, maybe even to the point of, whoa, I don't want to look at those logs because those are customer logs, and I want to stay far away from that, which also means it's sometimes harder to troubleshoot certain kinds of problems. It also means that one of the things we have to do is scan for Bitcoin miners, because anybody can sign up and you don't even need a credit card. So we'll periodically get people saying, oh, you're sending spam, or oh, you're engaging in some other kind of abusive behavior, and we'll need to go and figure out who that is and take them off the platform, which is, I think, something that PCF operators is not going to be as much of a normal part of your day-to-day. The other reason, actually, before we move on from this, the other reason that we run CF deployment, or the real reason that we run open source CF deployment, is that we're a really important part of the PCF R&D process. A big part of our job, a big part of our mission, is to deliver production feedback to the developers before it gets shipped into PCF and before it becomes part of that quarterly release cycle. We really want to find problems before we ship them out to you fine folks in the audience, because it might take up to 3 months to ship the fix. And it's just in general, like, it's just much easier to find a problem with code that you wrote 3 weeks ago than it is to find a problem with code that you wrote 6 months ago. So Pivotal Web Services, in addition to being a really excellent place for demos and a good place for people to run applications on PCF, either before they get their own PCF or in, maybe they don't have a big operations team and they don't want to invest in that yet, they can run on PDubs and then move those apps straight over to PCF if and when the time comes for them to do that. But in addition to that, we're a really important part of delivering feedback about how things actually work in production to developers. Cloud Foundry isn't Cloud Foundry if it's just sitting in a box somewhere not serving traffic. It's only Cloud Foundry when people are using it and when apps are on it. And so we're what allows developers to see a real Cloud Foundry and not just a lab environment. So a big part of what we do is deploy, pushing the button. I was hoping to be able to show you our actual deploy pipeline, but it looks like my computer can't deal with the number of boxes that are on the screen and be driving this big monitor here at the same time. So unfortunately, we're going to have to skip that part of the adventure. Our deploy process takes up to 7 hours. It depends on what it is. We spend a lot of our time doing deploys. We have a pair working on deploys and sometimes 2 pairs every day, which I think is probably more than most people who run Cloud Foundry, even people who are running the open source side. We're running over 350 VMs. I don't have a precise number, mostly because it changes on a pretty regular basis. We will scale up. We might scale down, like we've scaled up for Spring 1, but we'll probably be scaling down next week. We might be adding a component, we might be removing a component, we might be making a topology change. That shifts around a lot. Deploys can take up to 7 hours with that number of VMs, with about, it's actually over 350 VMs. That's the number of Diego cells that we have. So we have even more than that in the main control plane. We have like 16 API nodes, I think. That number of Diego cells takes a long time to roll. Especially, we have it currently broken out into 10 chunks, so that takes even longer, because then you've got the Bosch like startup and stop time on top of the rolling time. That's a number that I would really like to get down at some point, but it's where we are right now. We could drop it by scaling up, having a little bit more free space to move apps around, and then we could turn up our canaries, but we haven't, it hasn't gotten painful enough yet, so we haven't made the change. So the kinds of things that we deploy new CF versions when they come out. We try to do that within a day or two, again, because of that fast feedback. That's one of the core things that we're trying to do. It's one of those things we've actually gotten good enough at it that we don't think about it that much, which is kind of a nice place to be, but also one of those things where you're always looking towards the horizon and not stopping to think like, hey, wait, we just do a full deploy of this thing twice a week. That's crazy. We deploy new Bosch director versions. Dimitri, actually, the PM for Bosch, pretty regularly comes over and is like, hey, have you deployed next version yet? It's got some good stuff on it. Like, I really want to see that. Like, hey, deploy it. And we go, yeah, Dimitri, look at the deploy queue. It's prioritized to talk to the PM. So, you know, they are excited about this. We actually don't prioritize Bosch director. We prioritize Bosch director versions pretty highly, but Bosch is, unlike almost everything else in Cloud Foundry, it is still that one single point of failure. So we are in the delightful position if anything does go wrong. We have the Bosch team right there. And so we have on more occasions that I prefer to think about, run some kind of hot patch thing, because the director's in Ruby, right? So there have been times when Dimitri has gotten onto the box and written some code there to get us running again. That doesn't happen very often, but it does happen. And so, but you know, then that gets fixed, that fix gets shipped out. Nobody but us ever has to deal with that particular problem again. We deploy new stem cells, we turn new features on and off, we add new components. We actually just added this week, well, within the last couple of weeks, I'm not gonna say exactly when, we added the permissions module, which is gonna take over some like role-based access responsibilities from CAPI eventually. And we rolled out Bosch Process Manager, which if you understand the words, it might get rid of Bennett someday, should make you very happy. Yeah, some people know what I'm talking about. Yeah. We're gonna run Bosch processes inside of containers. It's gonna be great. Just to give you a little bit more of an idea of the kinds of things that we deploy, this is actually about half of our deploy track from this week. So you can see we did some stuff for Spring. We had a little UAA work to do. We added a Bosch DNS alias for that permission service. Added an extra AZ because we're the team that maintains the cloud config. So there's some shared resources that Bosch has that Bosch uses for all deployments. So if a team that's running their own deployment needs a change to that, they'll go through us. We rolled back instance identity. We discovered little tiny problem with it, where after 2 days, if you, I think, scaled down and then scaled back up to that specific number of app instances, those app instances wouldn't actually start because Diego thought they were already running. So we rolled that back while we're waiting for a fix. And again, that's the kind of thing, that's the kind of learning that we get from having a production team in-house. Because those kinds of tests, those things that only happen after 2 days or a week or 2 months are expensive and really hard to find in lab conditions. We do tons and tons and tons of testing and it still doesn't catch everything. And you know, the observations that we do on PWS still don't catch everything, but we do catch more because we have this production system. Bosch Process Manager, rolled out but off. We'll get to a little bit more about how that works later in the talk, but we do feature flagging on the Diego fleet. That's why it's broken up into 10 chunks, is so we can selectively turn features on and off different parts of it, which is super, super nice. Everybody should be able to do that. And then we updated our Concourse. That's always fun. pro tip, by the way, for Concourse folks, if you're running Concourse, limit your build history to some kind of sane number, because otherwise Concourse will, again, I see people who know, otherwise Concourse will store everything that it ever did for any job in its build history, and then you'll try to do an upgrade, and it'll load its entire database into memory, and then you'll have all kinds of bad things happen. So you limit your build history, your Concourse upgrades will get like 300% smoother. So Bosch is a really, really important tool for us. Unfortunately, I don't have time. Like, I could do a whole talk on Bosch. So I don't have time to go into a ton of detail about how it works, what it is, but it's basically industrial-grade configuration management. I don't know exactly why it's a clam. I mean, I can tell you it's the Bosch outer shell, but that still doesn't answer the question, why a clam, you know? Like, I can see why they saw, oh, maybe clam. I can't see why they decided, yes, clam. The short version on Bosch, the like micro elevator pitch, is it's a murderous robot nanny for your VMs. So you're gonna tell Bosch, this is what I want all my VMs to be set up like. It's gonna say, got it. It's gonna set them all up that way. If one of them falls over a little bit, stumbles, it's gonna be like, oh, I'll restart you. And then everything will be good again. If one of them really misbehaves, though, it will drag it out into the back and do God knows what with it, and then bring a new one out of cold storage and clone it. This is really, really great as an operator. This is really, really powerful. We don't use this as much as I think probably folks who are running this themselves should, mostly because we want to capture specimens for observation when they do something weird. But so many problems that can happen, especially with distributed systems, are just a weird thing that happened once. Who knows? And Bosch lets you not worry about those weird one-off problems. Just pitch it, start over. Like, if it happens again, then we'll look into it more. And that's an attitude that, you know, you can take that too far, it can get dangerous, but it's also just really nice to be able to go, oh, that one's no good. Concourse, of course, is our other really important tool. It's a really great tool for developers. It's also a nice tool for operators. We have had some struggles, especially because we run a multi-tenant Concourse that many people are on. Concourse is, you know, in that stage of software development right now where they're learning how to handle really large workloads, or even like we probably have what's a moderately large workload. All that said, I still really love Concourse. I love working with it, and you probably want some kind of CI system or some kind of continuous thing doer, or some kind as an operator of cloud systems, because cron jobs don't really do a whole lot for you if you're running hundreds or thousands of VMs. So you need some other centralized place. Like, this is where we do our deploys this way. We do our own CI for the tools that we write this way. But then we also run some timed jobs. This is where we run our Bitcoin miner detectors, for instance. The ability to do deploy pipelines is also really nice. It lets you encode what can sometimes be fairly complicated procedures in a way that doesn't have to be like documented and doesn't have to be transferred with language, which is really nice when, like, you know, I might rotate off of the deploy track for a couple of weeks, I might rotate back on, a bunch of things are different. I can understand what those changes are by, you know, well, asking my pair, but also by looking at the pipeline. And the pipeline's gonna protect me from accidentally forgetting to do something. So another big thing that we do besides deploy is we monitor the system. Unfortunately, the main thing that I have to say about monitoring it, metrics are hard. Metrics are really, really hard. They're so hard. They're hard to use well. They're hard to teach people about. This is one of the biggest challenges that we've had, I think, with rotating people. No, I love the bird. We're not getting rid of the bird. We're going to sit. This is a theme, by the way. This is going to be a theme that's going to come up again. This is one of the biggest challenges, I think, that we have because we did that ops rotate off, dev rotates on thing, and because we did like reduce the specialization level of our operators, is that metrics are this whole deep ocean of terminology and technology and potential problems, and people always have these questions. It takes a long time to teach people and how how we collect metrics, why we collect metrics that way, how we set up alerts based on those metrics, why we set up alerts the way that we do, why Datadog won't give you your data points, why it does weird smoothing things, why you can't just set up an alert for, okay, if this metric is down for 10 minutes, then I want to fire. You can't do that in Datadog. And it takes a while for people to understand why. And so that's a cost, that's a trade-off to people, to having people do this who aren't, deep operational expertise, deep expertise with things like time series databases. We try to get some control over that with dashboards. Sometimes that just makes the problem worse. This is a bunch of no data stuff, mostly because this dashboard's old, and we haven't updated the metric names in there to match some of the newer metrics. Like, a bunch of the metrics changed, and so the dashboard's no longer up to date. But like, it's just all a bunch of squares. And so now, instead of learning how the metrics work, now I have to learn what all the squares mean. And it helps a little bit, but not a ton. And then on top of that, when you get to the alerts part, when I rolled onto the team, and even actually before, I remember working with CloudOps people, and their phones would start buzzing, and I'd be like, what's going on? I was like, oh, we got Paige. It's fine, don't worry about it. Which is not how you want people to react to being paged. So we had all kinds of alerts going off all the time, all kinds of pages going off all the time, and that trains you that alerts aren't important, the pages don't matter. That's really, really bad. So we had to figure out some kind of way to get that under control. We still haven't done that completely, but the service level indicators model has been really useful for us in kind of winnowing down what stuff we keep track of and what stuff we don't, and what stuff is really critical to transfer to people initially, and what stuff they can learn over the next couple of months. If you're not familiar with service level indicators, go read the first couple chapters of the Google SRE book. It's available for free online, it's really good. The first 6 chapters in particular have some general operations principles. The later parts of it are specific case studies of this or that huge data-driven service, which is interesting, but you can get a lot of the value out of that book in the first 4 chapters. But the basic idea is that you're gonna specify a small number of things that you can measure from the user perspective that matter to the users, and then you're gonna measure those and you're gonna report on them. So in our case, we started measuring push success. We have a job in Concourse that once a minute pushes an application, measures how long it takes, measures whether it's successful, pushes that to Datadog. Then we report on it on our dashboard. And it turns out that that gets you a really, really long part of the way. The other metrics, a lot of those little detailed metrics, a lot of those metrics, Diego outputs things like the number of Go routines that it's running. It outputs the number of application instances that are crashed. Those are really useful when you're debugging, when you're trying to understand why a problem is happening. It's not so useful when you just get a metric that's oh, there's too many crashed app applications, when you get a page for that, or you get a page for, oh, a memory threshold is too high, and you're just do I care? Is anything wrong? So we've had a lot of success in just sort of ruthlessly prioritizing alerts that mean something to a human, because it's just much easier to process those and deal with those at 3 a.m. Or even just, anytime you get paged, you're stressed out. You're not working at, 100% necessarily. It's easier to deal with that kind of thing, and it's easier to understand that even if you haven't worked with it very much before. It's also more resilient to change, which is kind of an interesting property for alerts to have. It's more likely, those white box metrics, especially things like the CPU thresholds and the RAM thresholds, the appropriate resource usage for the system will change over time as the system changes, so you have to sort of constantly be updating that. You're always gonna wanna be able to push. That, as long as Cloud Foundry is around, CF push is gonna be important. 5 years from now, I'm gonna be eating my words on that. It's all gonna be, you're just gonna push directly to GitHub, and CF push is gonna be this forgotten relic. The other big thing that we measure is application availability. Maria's not happy with me. I took this picture earlier today. We had a little tiny little outage today. Not a big deal, but a little bit of application, a little bit of routing downtime. Basically, we had an issue where one of the components in our routing system got itself into a snit and dropped some routes, and then the router was like, oh, those aren't there anymore, I'll stop registering them. And then some people couldn't get to their apps, including the app that we use to test this. So the other thing that's really nice about service level indicators is that because they are human comprehensible, they're also business comprehensible. They help you have a conversation with other developer teams, with business people about what's the experience that people are having right now on the platform. Is that okay with you? And it moves that conversation away from operator, keep the system up, to hey, we can keep the system up, we'll just stop deploying. Like, the system will be fine if we don't mess with it. People usually don't like that exactly, but it's better because they're the ones who want you to keep deploying. Like, the feature teams are the ones who we want to keep getting validation about what's going on. And we want to ship new shiny features to our users. So putting that question into the hands of the people who actually care about the whole thing, and getting out of that business of ops people pushing for uptime and developers pushing for deploys it's a really nice little judo move there. There's a couple of other things you can see that we measure. We care a lot about memory because PWS charges by memory, so memory is usually the thing that is limited in our system. So we keep track of total available memory. We keep track of how many 4 gigabyte chunks there are, because that's how many apps you can actually push right now. You can see we've got actually a lot of room right now. We wanted to make sure that there would be tons of room for any Spring 1 demos that were going on. So you really want, I think, people to be able to trust your system, to be able to trust the robots. Like, this is something that I think about a lot, is that you're in a relationship with the machine. You're not just, oh, I'm telling the machine what to do, and then it does it, and then, like, you actually have an emotional response to machines. Like, if you get paged a lot, you're gonna have an emotional response, have an emotional relationship with that system. So this is another reason it's important. It's really important if an alert fires and it didn't actually require human operator attention, fix that alert. Like, people will say every time, oh, but what if it, like, no. It is damaging the human's trust in the system right now. And that's basically the most valuable, like, trust is the most valuable thing that you have in operations. Trust between humans, and trust between humans and machines. So we actually sometimes try to make our monitoring cute. This was a deliberate decision. Pushums the cloud tells us when the SLIs are failing, in part on the theory, and we're still experimenting with this, but on the theory that humans are going to be more sympathetic to a cute misbehaving machine than a not cute misbehaving machine. It does seem to help. We do seem to like it, but it's just something that we're playing with. Another practice. Again, this is just sort of a whirlwind tour of cloud ops. Postmortems are a bigger topic than I can get into here. The Google SRE book talks about blame-free postmortems. There's a lot of information available online, various agile sources. These are a couple of these are the things that we try to achieve when we do a postmortem. We don't do a postmortem for absolutely every incident, but we do for most of them. It's really important to get everybody into a room and just do that. What went well, what didn't go well, blame-free retro. That is actually, since I'm up here handing out dubious advice, if you're not doing retros on a weekly basis, just start. It's the easiest piece of sort of extreme programming, agile, to just pull in and start doing it. It's just getting everybody into a room and having some cheese and saying, what went well this week, what didn't go well this week. But yeah, we start with building a timeline to generate shared understanding so that you're not arguing about facts in the part where you're talking about what went wrong and what needs to be changed. Note changes, decisions, actions, hypotheses. Try to get user impact in as much detail as you can. We found that this limits catastrophizing. Like, what people can imagine having gone wrong is often much worse than what actually went wrong. So if you just get concrete about, like, okay, no, this particular, like, okay, yes, we had an hour of the push SLI being down. But that's because the push SLI has to delete in order to measure success. And the problem was that you couldn't delete anything. And we checked, and nobody tried to delete anything on the system during that 2 hours. So it was in theory very bad, but in practice, okay, you couldn't delete an app. Like, that's not the worst thing in the world. Resist the urge to predict outages. This is something that comes out of basically every postmortem that we do, is people will dig into the metrics, and they'll find some indicator that 2 hours ago, if we'd been looking at it, would have told us that this was about to happen. And they'll go, oh, we should set up an alert. That's how we ended up with, dozens of alerts that nobody cared about. Because what you're doing there is you're encoding yesterday's problems into your learning system, not tomorrow's problems. There's a bunch of reasons why I feel strongly about this. There are some exceptions. In particular, I suspect that if your response is largely machine-mediated, then it probably makes more sense to look for ways that you can predict when things are about to happen. But when you still have humans involved in the whole process from beginning to end, trying to predict outages and trying to catch them before they happen is probably not where the low-hanging fruit in your downtime problems are. The other big thing when we're on the subject of postmortems, I am pretty much every postmortem that we do, me or the facilitator or somebody else will have to say, whoa, whoa, hang on. Blame-free retro means no taking blame for yourself. We have a pretty good culture at Pivotal, I like to think, and people are pretty kind and empathetic and don't try to blame each other. But even very thoughtful engineers will say, oh, yeah, I screwed this up. I pushed a deploy, I pushed a config change that I shouldn't have. I made this typo. I've done this. I've taken the system down because I pushed a bad cert, like a cert that didn't match its collaborators, that I thought, well, I think that this is probably bad, but it's okay because this cert isn't going to be used unless I also change this other property. That was wrong. System went down, push went down, but whether or not I was at fault in that, you're not going to be able to stop humans from making mistakes. You're not going to be able to stop humans from making typos. So because that's impossible, you just take it off the table and you say, nope, can't do it. Let's move on to things that we can do, like changing what the machines do to make them safer, to make it safer for humans. So what is a strategy? Is working together. Returning to our friends, the Raccoons, I love these little guys. I love them because they do things like this. At 1:24 a.m., operations reported a Raccoon attack on the Linac gallery. It seemed to be a coordinated effort. Go look this up. Just Google Linac gallery Raccoons, and you'll see the whole report from Fermilab. They got into the lab, and they got chased out, and then they built a barricade, and they got chased out of that, and then they came back and they did a reconnaissance mission, they counterattack, it's crazy. Raccoons are a problem. They have hands and they can work in teams, and that's really all you need, right? So we try to optimize for teamwork, for pairing. We pair. Pairing is really, really good for ops. Pairing is one of those things that's wow, why did developers invent this and not operators? And there's reasons for that. It helps you transfer context within the team. Often the key thing with ops is knowing that one little change that got made a week ago that is involved in whatever problem you're currently troubleshooting. And when you double the number of people involved in every change, you radically increase the chance that someone involved in working on the thing that happened 2 weeks later because of it is going to know about that and remember it. It also just is a really good way to train people. That supports team rotation. So we were able to do what we did, rolling a bunch of people on, rolling a bunch of people off, transferring operational knowledge around the company that way. We were able to do that because we pair, everybody pairs. It makes it really easy to, not really easy, it's still hard. It's one of the harder things that we do is training people on new teams all the time. But it makes it easier and more possible for the team to rotate. It makes the team more resilient. We can lose people and it's fine. People can go on vacations, it's fine. People can decide, nope, ops is not for me anymore, it's fine. So that's one of those like organizational benefits that you get from doing a lot of pairing. It does reduce typos, at least in theory. A lot of the worst outages come from really, really simple little things that people do. And so having just somebody looking over your shoulder when you're doing those little simple things is kind of nice. And it enables incident swarming. So when we have an incident, basically what happens right now, I haven't gotten into too much detail about how we respond to incidents, mostly because that changes all the time based on postmortems. So I'm focusing on kind of the meta level of how we think about it. One of the things that happens right now is we start a video chat, and we publish that to the main CloudOps PWs channel. And then any of the CloudOps people who are interested can get involved in that incident and can start watching what the pair is doing. Anybody on the other teams whose software that we deploy can jump in. Sometimes PMs just jump in to watch. Sometimes people jump in because they want to be available to help. Pairing and pairing culture, pairing especially, again, if almost everybody has been involved in something, if many, many people on the team have been involved in something, when something goes wrong with that thing, there's a bunch of people who have the context to just jump in and help out. And that's one of those things where you don't realize that you're getting that benefit in the moment, and then 2 weeks later you're like, oh wow, it's not just, oh, we did better work as a pair in that moment, it's this enabled the team to do something. Cons with pairing, so I actually can't recommend that if you're not pairing right now that you just go out and start. I mean, try, but be warned that it is hard. It's hard to do well. You have to be, there's some skill involved. You have to be pairing with someone who's interested in doing it. It's really easy when two people who don't know how to pair well or have just been told to pair, it's really easy to just end up like one person watching the other person type, and that's one of the most soul-crushing, miserable things that you can do in front of a computer for 8 hours is just watch someone else type. Even if they're narrating as they type, that's an anti-pattern. Like, that's one of the ways that even people who are very good at pairing and do it a lot can end up pairing badly, is just driving. It's like, oh, I'm talking while I'm driving, so I'm pairing, right? No. You need both people to be engaged. You don't have TDD Pong when you're doing operations, unless you are writing code. And we do write some code, but not nearly as much as many of the development teams. TDD Pong is basically, I write a test, you make it pass, you write a test, I make it pass. It's just this little game, basically, you can play that gets you into that back and forth rhythm of pairing. And so you don't have access to some of those little tools and tricks that you do when you're writing code. Pairing and a lot of the practice around and a lot of the advice around pairing is focused on coding TDD. And so you don't necessarily have those frameworks as an operations team. It's also hard to pair write and research, which is something that you have to do a lot as an operations team. You have to figure out how to do things. You have to write up incident reports. We solo to do this for the most part, although it totally is possible to write in a pair. It's just a whole other skill. Like, it's a separate skill from writing code or doing operational work. And so you have to learn how to do that if you want to do it in a pair. So I think we've got time to get into this. Oh yeah, we're doing fine. A lot of what we do is experiments. A lot of what we do is trying things out that might become part of the product someday, or figuring out how to do something the product has told us that we need to do. We're getting better at this over time, especially as we pull that into our mission. For example, you may have heard of CredHub. CredHub is the latest in a series of pieces of work that Cloud Foundry is doing to try to improve credential management. We built what in retrospect was pretty clearly a precursor to CredHub a year or two ago called Secret Sanitizer. Because basically the security team came to us and said, and I'm horribly oversimplifying this, it was a much nicer conversation, but they said, wait, what, you're storing your credentials in your manifest and you're pushing the whole thing to go, oh, please stop doing that. At least separate out put the credentials at least in a different GitHub repo. So we built a tool that pulls credentials out of manifests and stores them in files and then stitches them back in if you want to. And again, in retrospect, we actually were able to convert to CredHub, not super seamlessly, but like there were places where we were just like, oh, this secret sanitizer generated file, we can just feed it straight into Bosch and use Bosch's new config server, technology and just use this as a var store. And there were other things, though. There were other differences between the two approaches that made our lives hard. If we'd been thinking, I think at that time, what we were doing in terms of, okay, well, let's do the first draft of this on the project, and then deliver the feedback that we learned, deliver what we learned to the development teams. That might have been a less painful process. Spikes, incidentally, I should have mentioned at the beginning, are an XP term. They basically mean try to figure out how to do something by writing code, and you're not necessarily going to TDD that code. You're not necessarily going to do various kinds of things that you would do to make it long-term sustainable. You're just going to do a little spike, do a little proof of concept. This is where we are with Diego rollouts right now. This is both a spike in itself and something that enables experimentation. We broke Diego into 10 equally sized chunks. So we roll out changes to 10% and then 50% and then finally 100%. And Diego, Garden, and GrootFS teams can help us evaluate, okay, are the cells in each part of the system behaving the same? They can look at the metrics and do that. This is really cool and really nice. If you're not already doing feature flagging, start. Feature flagging is so cool. It lets you see all kinds of things that weren't possible otherwise. It lets us be a little bit more adventurous in what we roll out. We can go, okay, we're going to roll this out to 10% of the fleet, and if it looks like it doesn't work or it's hurting in some way, we can just pull it back, and we'll only have impacted a small number of apps. Ideally, actually, we haven't impacted any apps really, because all we've done is take down one instance of the several instances that people are running on the platform. It let us do things like A/B test the file system. So I'm going to try to explain this without getting too inside baseball with Cloud Foundry. Also, I don't fully understand the problem involved here myself, because this involved we ended up having to report this issue to Canonical. This was an Ubuntu kernel thing. But we basically had this problem where Diego cells would just lock up. They would just stop working. And the first couple of times we went, oh, into the sea. Bosch will bring it back for us. But then it kept happening. And they locked up in a way that was we couldn't even SSH on to see what was going on. We couldn't even look at the logs. We had they would just go dark, which was weird. It turns out that they were all going into D state. Sorry, not the cells. Many of the processes on the cell were going into D state, which again, this is one of those things that I kind of, sort of, mostly understand. They were waiting to hear back from the file system, and they were just waiting forever. And we figured that out through a long series of different experiments. We figured out a way to open up sustained SSH tunnels and just be ready and be able to SSH into a machine when we needed to. But then we discovered that if you touch the file system at all, that session would get killed. And then you would have to wait for it to happen again. This only happened once every couple of weeks. So we had to be pretty careful when we took one of these chances. When we got a specimen, we had to spend some time on it. And I actually think we might still be in the process of tracking down exactly what was happening here. Maria's nodding, so yeah. But one of the breaks that we got was that because we had GrootFS, the new root file system manager, we had, I forget if it was GrootFS itself or a new version, but we had that rolled out to part of the Diego fleet and not all of it. And so we were able to see over time, oh, hey, this problem only happens on this subset of cells. I bet it has something to do with GrootFS. And so that let us narrow down to, not just the technology, but the team. it let GridFS decide, okay, we're going to, since we have some idea where this problem might be, we can invest the time ourselves in building some extra diagnostic tooling and put that on there so we can get even more information the next time one of these happens. A/B testing, feature flagging, it's really nice for those kinds of things where it doesn't happen very often or it happens intermittently or sporadically, and so you just need to collect like some patterns. Basically, you have to do some pattern recognition. We tested Bosch Repave earlier this year. So you might be familiar with the 3 R's, rotate, repave, repair, kind of the cornerstone of our security strategy. That repave one is the idea that if you're ripping out your VMs and replacing with new ones all the time, that you've really limited the access that someone can get to your system. You have limited their ability to exploit vulnerabilities that give them inappropriate access. And we do this a fair amount just in normal operations, but we wanted to turn it up even more, and we wanted to be recreating all the VMs on a regular schedule as just part of PCF. So the Bosch team built us a Bosch release, actually, that did this. We started running it. We discovered some fun problems. We found there was some kind of race condition that caused Bosch to lose track of VMs when you were just recreating things all the time. Bosch would forget where a VM was, basically, and then go, oh, well, it's gone. I better make a new one. And then get upset because the IP address was already taken and it didn't know what was there. And it was just like, Bosch, why are you like this? You're so good, and then you're so not. We also found, and this was just, it turns out that this happens occasionally when you're recreating tons and tons of cells. I think that this problem has been long since fixed, but it turns out this happens when you're recreating tons and tons of cells, and this was just the first time that we'd been recreating all the Diego cells all the time. We also, though, we found out that the current way that Repave, like the whole idea of the way that Repave was implemented was with the Bosch recreate command, which takes a deployment lock, which means that you can't do anything else with any of the cells in that deployment, any of the VMs in that deployment while that recreate is happening. And that caused us some operational friction. That caused us problems as operators. We would come in and we'd be like, oh, we can't do a deploy today because Bosch is recreating everything, and we just have to wait for that to finish. And then we were like, well, we could do it at night, except that sometimes these problems happen, and that doesn't, like, I don't want to get paged overnight. And actually, based on that feedback and based on that experience, the Bosch product team basically went, okay, we're going to just send this back to the drawing board entirely. We're going to think about new ways to do this. We're going to think, we actually still have turned Bosch Repave back on in the bottom of our deploy check right now, so if we do ever get to it, we will turn it back on and see if it's maybe a little bit better at this time. But at the same time, Marie's not enthusiastic about that idea. So it's good that Bosch is also at the same time thinking about, well, maybe we could do a totally different thing, like Bosch does this totally out of band at the deploy process, and just, if a VM is older than 24 hours, it's going to schedule a single instance operation to kill it and recreate it. And that's the kind of operational feedback that, really is impossible to get other than talking to operators, watching operators work, being right next to operators while they complain about your product. And that's, that's the value that we provide to the PCF R&D organization. Not just production traffic as a service, but also complaints about your software as a service. I will happily do that, by the way. Like, I will complain about, like, that's how I got my start in software, is complaining about software for money. I'm good at that, turns out. My parents were like, oh yeah, that seems like testing. That seems like a really good job for you. You're really good at being critical of other people's work. I was like, thanks, Dad. On that note, we've hit the 10-minute mark, and I want to leave a little bit of time for questions. I do recommend, if you haven't read it, reading the SRE book. I also recommend XP Explained by Kent Beck. It is, old, but it's still good, and it's got some things that even if you do this stuff all the time, you'd be like, oh, that's part of XP, like simplicity, that makes sense. And then if you want to talk to me about Cloud Foundry operations, you can get on the open source Slack. The CF operators channel is there for you, whether you're running PCF or anything else. If it's Cloud Foundry operations related, we want to hear about it. So thank you.